Okay, this is web assigned 6D, number 7, and it read, a potter's wheel, a thick stone disc of radius 0.5 meters and mass 120 kilograms, is freely rotating at 50 revs per minute. The potter can stop the wheel in 6 seconds by pressing a wet rag against the rim and exerting a radially inward force of 66 newtons. Find the effective coefficient of kinetic friction between the wheel and the rag. So first, we should start by finding the moment of inertia, and we can do that by, since it's a stone disc, so its moment of inertia should equal 1/2 mr squared, and they give us m and r, so we can just plug in what they give us. M is 0.5, or no, M is 120 kilograms, sorry. R is 0.5 meters, and that'll be squared. And this comes out to be 15. And then next we should convert it gives us it gives us angular velocity, 50 revs per minute, but we have to convert that. And this is where some people mess up because they forget to convert the revs per minute into radians per seconds. So that's why it's important that we do that now, so we don't forget later. We're just going to 2 pi radians, and then by 1 minute and 60 seconds. Revs cancel and the minutes cancel, so, and then this gives us angular velocity is equal to 5.24 rads per second. Okay, so now now that we have that, so what we need to do is find the torque, and we have the moment of inertia, but we need the angular acceleration. So what we can do, since it says that we can do the change in the angular acceleration in the angular velocity is equal to, or the change in angular velocity over time is equal to the angular acceleration. So 0 minus what we got up here, it's angular acceleration, it's angular velocity, 5.24 over 6. We get that 6 for the 6 seconds that it gives us after 6 seconds. So, and then that comes out to negative 0.87. That'd be rads per second squared. Okay, so now we can plug in our moment of inertia and our angular acceleration, and we get 0.87, and that comes out to be negative 13.1 for the torque. So now we need to find the torque of this force, 66 newtons, so we can just multiply that by R. So negative 66 times 0.5 is equal to negative 33. And now we can put negative 13.1 over negative 33 to find the coefficient of kinetic friction. That'd be 0.397. So this is your final answer. And so basically, just remember to, in this problem, convert, because that could mess you up. Convert the angular velocity. Make sure you do that first before you do anything else. And basically, what I learned from this problem was that you can use like torque to help find like forces, or like the coefficient of kinetic like friction, for example, you can use torque to find that. So yeah.